Hello, this is Daniel Stepp. This is my Physics 2 Lab 3 Circuits Lab reports. Sorry. The introduction. The purpose of this is to predict and observe the behaviors of resistors and capacitors in circuits. And we used a couple of principles from physics, such as Kirchhoff's law, which is that the junction law about how voltage or current in equals current out at a junction, and that Kirchhoff's voltage law, where the total voltage in a loop is zero. We also learned that, or used the fact that voltage equals current times resistance, and that Q equals capacitance times voltage. Brief preview: the total voltage change across a circuit is zero, and the increasing in resistance and increases the charging and discharging time of a capacitor. This is the lab. It's a little diagram of what we set up at first, and a little picture of it. It's a little messy, sorry. Where we have a battery connected to ammeters connected to resistors of different resistance, 47 and 100 ohms respectively. The results, once we calculated using the resistance equals voltage over current, we found that it was around 47.5 and 101.3 ohms. Here's our work shown on the right. A little bit different than perfect, like but shows that it was very close to the actual answer. The second part of the lab, we charged up a light bulb with a capacitor and then saw how the light would dwindle over time. That results are graphed here, and for the 10 ohm bulb, we saw that it took around 35 to 36 seconds to fully dissipate, like the light to go away to zero. And same for the 20 ohm bulb, it was almost double time. It's kind of crazy. So it took a lot longer for the 20 ohm bulb for the light to go out on the 20 ohm bulb, which was kind of crazy when it was happening live. But it shows just how kind of results of the lab, just kind of how the more resistance, the longer it takes for the capacitor to discharge. Potential errors: there could have been a lot of things that went wrong in this lab. First of all, just there's a little bit of resistance in the wires. That could have been something that could have happened. I'm not entirely sure. There's also a chance just the ammeters read it wrong, or other things could have gone wrong. We could have, set up something wrong. The wires could have been a little faulty. There's a lot that could have gone wrong in this experiment, to say the least. What if you charged a capacitor with no resistor in the circuit? How quickly would our ideal model predict the capacitor to reach full charge? Will this prediction happen in real life? It would charge up really fast. This would never happen in real life, though, because stuff like that doesn't happen. Life ain't perfect. Things go wrong in life, and you have to bounce back from them. You have to, adjust. You have to just take that, know that that's a fact, and know that you can't just assume things are going to go perfect. And I just really want to thank you so much for everything, for listening to this lab report. And I hope that you had a fun time, that you learned a lot about resistance, about capacitors, and about wires, and about circuits. I hope you know that, in life, you're going to have resistance. There's going to be a lot of resistance in what you do, and the people around you, and the classes you take, and the jobs you apply for. But it's important to know that resistance equals voltage over current. So if you want to, fight through resistance. Okay, I'm over 4 minutes now. I feel confident stopping this recording. Thank you for listening, and I hope you have a good day. And I hope I completed everything on the syllabus, or on the rubric.